This is 4.5 out of chapter 4. So what we're going to be doing here is we're going to be working more on quadratics and solving quadratics. So what we want to make sure that we understand is that there's several different ways to solve a quadratic function. You just need to know what is the best way for the problem that is given to you. So in the last chapter we talked about factoring, and factoring is a very, very important part of it. The second way that we're going to talk about is with square roots. And square roots are going to come into play mainly when you're missing the middle term, and you'll see that as we go through. So first of all, let's talk about a number r is a perfect square of a number s if r squared equals s. For example, 4 is a perfect square because square root of 4 is 2. 9 is a perfect square because square root of 9 is 3. So it's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all of those that are perfect squares. It's when you square them, you get a number. That's the perfect square. The expression this is a square root of s is called a radical. And then the number that is underneath the radical is called the radicand. Okay, also we are going to learn, and we've talked about before, that you're not allowed to have a square root in the denominator of a fraction. That is called rationalizing the denominator. And then the last thing we're talking about is when we have to eliminate square roots and we have a plus or minus sign in between a number and a square root, we call those conjugates. And you'll see how to use those in a little bit. So before we really get into solving quadratics, we want to talk a little bit about how to simplify a square root. So what is really important to understand is that you can break up any square root into two numbers that multiply to be that number. So if you have a times b and place whatever number you want in there, you can break that up into two separate square roots. And the same thing is true with the quotients. So getting into this down here, we have square root of 24. The point of reducing a radical is to try and find a perfect square that we can pull out of there. So down here we have fill in the square of each number. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and we can keep going, 36, 49, 64, 81, and 100. Now I'm going to stop there. But basically what we're looking for is we're looking for one of these perfect squares that we wrote in here to go into what's underneath the radical, because we know that those are perfect squares and can be reduced. So when I think about 24 and the factors of 24, and you don't have to do this every single time, but I write it out. We have 24 and 1, we have 12 and 2, we have 8 and 3, and we have 6 and 4. What you're looking for is which of those numbers that we just wrote out is a perfect square, and 4 is. So what we're going to do is we're going to rewrite the square root of 24 as the square root of 4 times the square root of 6. Because I know what the square root of 4 is. The square root of 4 is just 2. So then our reduced radical is 2 times the square root of 6. Next one, we go 5 times 18. If we take 5 times 18, we get 90. So therefore we have the square root of 90. So we do that first. We combine these first, unless we can reduce one of them, which we could have here. But this is just to show you a little bit of the process. But we could have reduced the square root of 18. But now we have square root of 9. What goes into 90? Well, I know that 9, so the square root of 9 and the square root of 10, that's equal to 90. Square root of 9 is 3, so we're left with 3 root 10. This one up here, real simple. Take the square root of both top and bottom separately. Square root of 9 is 3. Square root of 64 is 8, so we're left with 3/8. Okay, what I want you to do is try these on your own and put your answers in the best of your ability into Edpuzzle. Maybe just use the words square root in front of what you're taking the square root of. So if you end up with, like, say down here we have 3 times the square root of 10, you can type it in like 3 square root 10 like that. And that way I'll have at least a good idea of what you're doing. So try those. Let's see how you do. So the first one, you should have gotten the square root of 25 times the square root of 5, which equals 5 root 5. And on the bottom, we had two perfect squares, 10 and 13, so you just get 10 over 13. I'll let you fill in the rest of these. You can use that to your advantage or as useful as you find it. for your own needs, but I'm not going to go through and square all of those for you. You can do that on your own. Okay, moving to the next page. Now we want to get into the next thing about simplifying radicals, which is using conjugates. So let's first talk about what happens when we have the square root on the bottom. So we have to rationalize our denominator when we have a square root on the bottom. So we have the square root of 7 over 3, which we can change to be the square root of 7 divided by the square root of 3, which is not okay because we have a square root on the bottom. So to get rid of a square root on the bottom, we multiply by the same thing that's on the bottom by itself over itself. Remember, the reason why we have to do top and bottom is because this is equal to 1, so it's not really changing this problem at all. So then we're left with the square root of 7 times the square root of 3 is the square root of 21 on top. Square root of 3 times square root of 3 is just 3, so we're left with the square root of 21 over 3. You always want to check to make sure that this top portion is reduced. In this case it is, that it cannot be reduced any more than what it already is. In the case where we have a radical on the bottom, but we have something else added or subtracted with it, this is where we do something called the complex conjugate. And the idea of this is that we will multiply both the top and the bottom by the conjugate, which is the exact same thing that you have, except it's the opposite sign. So instead of multiplying by 5 plus the square root of 3, we will multiply by 5 minus the square root of 3. The reason for this, and it's important to understand this, is if you remember when we were factoring, we talked about the difference of squares. Meaning when you FOIL something, if you have the exact same thing, but one thing is a plus and one thing is a minus, we know the middle term will cancel out. So what will happen here when we multiply is we certainly are going to have 4 times 5 minus root 3 on the top, which is equal to 20 minus 4 root 3. But on the bottom, what's going to happen is we have 5 times 5 is 25. 5 times negative root 3 is minus 5 root 3. 5 times positive root 3 is plus 5 root 3. And then root 3 times negative root 3 is just minus 3. If you notice, we have a negative 5 root 3 and a positive 5 root 3 in the middle here, and these are going to cancel out. And that's the whole point of multiplying by a conjugate, because they will always cancel out. So what we're left with here is 20 minus 4 root 3 over 25 minus 3 is 22. And now the only thing left to do there is to reduce each one of these. We can divide everything by 2. So that means we will be left with 10 minus 2 root 3 on the top, and we will be left with 11 on the bottom. So all I did was divide everything by 2 to reduce that fraction. So those are probably the ones that are going to give you the most trouble. So here's one for you to try over on the right here. Let's see how you do. So for this one, you should have multiplied by the conjugate, which was 4 minus root 5 over 4 minus root 5. On the top, we get 12 minus 3 times the square root of 5 over. And now again, if you do your difference of squares, you should have 4 times 4. The middle two terms will cancel out, so then all we're left with is square root of 5 times negative square root of 5, which is just minus 5. So we end up with an answer of 12 minus 3 root 5 over 11. Okay, moving on to the next part. Here's where we're going to be solving equations. So we have a couple of problems here to do. And this one is shown for you. But the idea of this is the only way that we can ever use square roots to solve an equation is if the squared term is the only variable that we have. We have to be able to get down to x squared or something squared, and that be the only thing left. Otherwise, we can't use square roots, and you'll see that in the examples that we do. So we're solving the equation the same way we always would, but we're isolating our x squared. One thing we have to be aware of, though, is when we take the square root of both sides of any equation to solve, it's got to be plus or minus. So that's really important to see, is it's going to be plus or minus because we get 2 answers. And then from there, we reduce as needed. So let's get through this example together. So we add 15 to both sides. So we're left with 2x squared equals 80. We divide both sides by 2. So we're left with x squared equals 40. We take the square root of both sides, and we're left with plus or minus the square root of 40, but now we need to reduce. So reducing this, we will get the square root of 4 times the square root of 10, which is 2 root 10. So x equals plus or minus 2 times the square root of 10. So hopefully that makes sense. Okay, so what I want you to do is I want you to see if you can do, how about number 12 and number 14? Let's not worry about number 13, so we can cross that one out. That's just a little bit, we're just going to try and save some time, so we can cross this one out. So just work on 12 and 14 on your own and put what you get for your solutions in the Edpuzzle, and let's see how you do. For the first one, you should have, remember, the key is here is to make sure that you bring every x squared to one side and every number to the other side so we have something to solve. So you should have ended up with x squared equals 14, which equals plus or minus the square root of 14. On this side, very big key, divide by 3 first. Now you could have gone through and multiplied the 3 through. You'd end up getting the same answer, and that's okay. But you should have ended up with x squared equals 4, which is x equals plus or minus 2. So that's really it for this section. Hope that makes sense. I will see you in class.